Good morning. I will be talking about my final project and about the course that is Programming 2 from the University of Belize. Um, in this course, we learned to write executable code in Python, troubleshoot the code, and debug the code for efficient runtime. We used libraries like NumPy and Panda. We use this more as towards data analytics to solve real world problems. For example, in this final project, we used data from BJAT, PAC, and ATLib scores to find the best predictors of an ATLib score and the best predictor for a PAC score. We also found the is mostly mostly the what does the grade depend most on? Is it the school? Is it the management? Is it type of funding? So all here in the table of contents. For example, the BJAT for all, no, the BJAT averages for all districts. This gives the average for each district and shows the highest. Same goes for funding, municipalities, and management. All of these were done for BJAT, PSC, and ATLib. After that, we were asked to find the correlation coefficient R and to show scatter plots of each of interesting relationships from BJAT paper 1 to BJAT paper 2 to see if any of these have any dependence on a particular on a particular score. For example, the BJAT paper 2 is heavily correlated with BJAT paper 1 since the correlation is 0.72. What this means is that BJAT paper 1 can tell you more or less what you will get, what score you will get in BJAT paper 2. That was heavily correlated. Also, PSC paper 1 and PSC paper 2 are heavily correlated. So if I get a high score in PSC paper 1, I should also get a high score in PSC paper 2. ATLib and English Math, that was correlated but not but more moderately correlated. There's still a correlation but not as high. You can still predict something out of that, but not it would be irrelevant for now. We also found the correlation between BJAT and PAC. So if you get a high BJAT grade, would you get a high PAC grade? The correlation was found to be 0.62. Shows moderate correlation, but good enough. What was not heavily correlated was BJAT and ATLib. As you can see, the correlation is 0.52. It's almost 0.5, which is not very good when you want to be predicting stuff. PSC and ATLib was correlated as well, 0.702. So the best predictor for the ATLib when comparing the BJAT and ATLib and the PSC and ATLib, the one with the highest correlation would be PSC and ATLib. So PSC your ATLIB is more dependent on your PSC than on your BJAT. Um, that can be thought of as maybe because BJAT is only how much 4 years away, whereas the BJAT is 6 or 7 years away. The time span between those examinations are very high, very very far apart. So it's understandable that they are not heavily correlated. So finally, what we were asked to do was to find the best predictor for the ATLIB and the best predictor for the PSC. So the best predictor for, oh yeah, the correlation between the BJAT and the PSC was moderately high, so we used that. And the correlation between the PSC and the ATLIB was the strongest, so we used that. So we'll be defining our functions. These are our functions. We used to find the y-intercept, the y-slope as well. Predicting BJAT PSC using BJAT. This was our procedure. Using a line of regression, we found a formula where you can plug in a BJAT score and you get as a result a prediction, a PSC prediction. And we found that to be this equation, and predicting ATLIB using PSC. Same procedure, just using the appropriate values. As you can see, the line of regression is right on top of the ATLIB predictions, and we can see the relationship very well here, as well as this other one. So at the end, we got another formula that predicts ATLIB grades from a given PSC grade. So in the end, we stated the formula and we explained it, and we can use this executable code cell to input our BJAT score. Let's say I get a 50 in my BJAT. So this will predict what PSC score you will get, more or less. So if I get a 50 in my BJAT, I will be getting a 53 in my PSC. And that will be for both PSC paper 1 and PSC paper 2. That will be the sum. Also, the ATLIB prediction, we use this formula that we got, and can run this, and we can input our ATLIB, our PSC score. Let's say I get a PSC score of 61. So the predicted sum of math and English ATLIB scores is 82. Well, some of my colleagues multiplied the English, no, the ATLIB math by 2, but I think it wouldn't be correct to do so. I thought that it would be better to sum the math and the English into one grade. That is because for the final BJAT grade that we use, we summed BJAT paper 1 with BJAT paper 2 to get one grade, which was BJAT. And then we used that all for the code. So we did the same thing for PSC, where we summed the PSC paper 1 and PSC paper 2 and we got one score PSE, and we use that out for our code. We processed it like that. So it would not make sense for us to multiply only the Atlib math paper and get a final score for the Atlib. It would not be it would not make sense because it would make more sense to add the Atlib math score with the English Atlib score. Add that, and then we will get a better representation of the overall Atlib score. Mm, some of these scores, when we add the math and the English, we got some scores greater than 100, but that was because the Atlib is graded differently. We could have appropriated these. We could have appropriated these scores by finding the total number of points that we can obtain, which would be probably more than 100 for the Atlib, and then divide our current grade by that total number of points, and then multiply that 100 to get a more no a grade that goes along with these predictions. Also, something I wanted to add was that when we were predicting PSE and Atlib, we were getting a lot of points down here. That was because some people sit, for example, PSE and Atlib, some people sit the Atlib but get a 0 in the PSE, probably because of absence or because no questions were done. These are outliers. So we removed these from all the Atlib, from all the data. That way we got different correlation values from our colleagues. So that is the end of the presentation.